This is the fourth session of AWS DevOps, and this is the continuity of Terraform. In previous session, we tried to install, we understand the concept of Terraform, AWS CLI, AWS Identity Access Management, user creation with some special policy, and we did all these steps. So these are the prereqs while you are working with the Terraform. We also install this Visual Studio Code, and we install this Terraform extension that will help us to write the code. So today we have to understand the syntax of Terraform, how to write the Terraform code. So our base infrastructure is ready. If I go to my CMD, so my CMD, I can verify my AWS CLI is working, my Terraform is good. Terraform version and AWS version both are installed. And just to verify the AWS configuration, we can again run the AWS configure. So you can see the access ID, the secret access key, and the region is set up in AWS CLI. So whatever I will run by AWS CLI, it will run on this region. Okay, now we have to understand the Terraform. So Terraform will use AWS CLI to connect with the AWS. So I wrote this Terraform syntax to create a VPC and then internet gateway, public route, public subnet, private subnet. Okay, the routes association with the subnet, elastic IPs, net gateways, key pairs, security gate group. Okay, everything. But it looks like horrible. I mean, how complex is this code and how we can write it? Definitely, it's difficult if you just look this whole code in one go. But believe me, it's very easy to understand. You just need to concentrate. You just need to focus on the concept, and you can write even more complex Terraform code. Once you got the idea of the syntax, you can do anything. We can take the leverage of documentation, and then it's very easy. So let's start. So what I did, I have my Visual Studio Code. I am going to create a new file for the Terraform. So remember, .tf is the file extension that is uh, read by whenever you will compile the Terraform. So it will read the files ending with the .tf name. So very first file name is main, and it can refer to the rest of Terraform files, but we will write initially everything inside the main Terraform. Then we will also understand its advanced level of concept, how we can write the modules and distribute the Terraform resources. But we have to understand main.tf today. So main.tf file I am going to create, and where I am going to create, actually I created a directory for AWS, and under the Terraform anywhere you can create. So I am going to create at this location, and in this main.tf file you need to understand some, you need to memorize some keywords just like the provider, and you can see the provider. As I wrote the provider, I just press enter. So everything is automatically completed. How is this possible? Because of this Visual Studio Code and the extension what I installed for Terraform. And you can see the icon of Terraform is added with this file. So extension automatically recognize this file and extension now knows whatever we have to write here, it will be the syntax from Terraform. So here provider name we have to provide in this inverted comma. So what provider name I can use? I am going to connect my Terraform with AWS. So I wrote AWS and automatically list down the AWS. I can also write down here Azure, Azure RM. So for to manage the Azure cloud, you can write the Azure RM. So, but today we just have to understand the AWS. Okay, these provider keywords defines that which cloud we are going to manage with our Terraform. AWS. We are not going to manage Google Cloud, Azure, Alibaba, nothing else, just the AWS. Okay. Now the question is, what's next? Under these curly brackets, what we can write? So the answer is we cannot memorize these values. So you can get the answer by getting into the documentation. You will search for Terraform AWS documentation, and on the registry.terraform.io, and under the providers HashiCorp AWS and AWS version 5.80. All the documentation is there. Just type here provider. So all the provider related information is given here. So you can see the AWS provider information is given here. So this is used to define which cloud we are going to connect. So here are the example of provider AWS, and then under this we can write the region, which region we are going to maintain, administrate under this Terraform code. Just we have to understand this right now. Other ways of using AWS provider, let me check. Yeah, here you see we can also use the access key. We can and also provide the secret key. We don't need to install AWS CLI, and we can directly provide this access key and secret key in this Terraform provider section. But this I will not recommend this because this will be in a plain format, and anyone who can read this file can access these keys. But this is also a way. Okay, and what else we can do? So there are you can also define the AWS and the config file and credential file. Yesterday I showed you for the AWS CLI, we can give the path of those files if those files are at some different location. So if your AWS CLI is working fine, you don't need to do this activity. Okay, just take care of your region under this provider. So just we have to write here region. So region is automatically listed down, and our region you have to provide. We are working in the region North California. We created some stuff. So US West one. So I deleted everything whatever we created manually. So under the US West one we will perform the activity. Okay, so this is the provider. So far right now what we have, I created this file main.tf by using Visual Studio Code. I'm going to save this file. Let me just increase the font size. Okay, so I just created this file, and this file is saved here. Okay, you can see the 1 kilobyte. Now I have to process this file. I have to run this Terraform code. So how can I run? Either I can go in the CMD and go to the same direct path where this file is available, or I can take the leverage of Visual Studio Code and I can open the terminal here. It will open the uh, Windows PowerShell terminal at the same location and from the same path where you open this file. So now we can run this ls command. The leverages, we can also use the Linux-based commands here. So, or either we can use the DOS-based commands. Okay, so main.tf file is there. Now we have to run this main.tf. So first command, whenever you are going to write the very first Terraform code, you will run Terraform command and init. So the init will actually pull down the required uh, providers, binaries, and it will generate a database. So it is trying to initialize, it is reading this main.tf file, and from this file it recognized that AWS is the cloud provider and it is installing AWS version 5.80 Terraform uh, variant. Terraform engine is already installed, but after reading this file, the HashiCorp latest version 5.80 is installed. And if I go to this documentation, you can see here on the top the AWS version 5.80. The older versions are also available, but it pulled down the latest version of AWS Terraform. What actually happened in the background? If I now just go to the directory, you can see this log file is created and HCL Corp log file HCL, and this hidden directory is created. I set in the view section of my this Explorer to set to show the hidden files. So Terraform directory under the providers, under this, under HashiCorp, AWS directory is created, and the variant that was pulled down is created, and for Windows or whatever OS I used, and then this binary is downloaded. So now the whole magic will be done by this binary. This binary is the whole AWS Terraform syntax, you can say. It will help us to compile and to provide, you can say, the auto completion of the whatever the services are available in the AWS are. Is this, you can say, this is a complete executable database and everything is available in this binary. Okay, now let me show you one more thing. If I use your RM remote management, just think like this is the region for the your. Just save this file and let me again initiate this. So it found that Azure RM, Azure Cloud we want to manage, and the HashiCorp Azure version 4.12 is available, and it is downloading its relevant binaries, and it's done. Now if I go to the same directory, just go to this level, here you can see Azure RM, this version for Windows, and its binary is downloaded. Okay, so far we are not going to manage Azure, we have to manage the AWS. So I just showed you how this Terraform will work, how the backend engines are working. So here the AWS binary is available. So I hope you got this point. Now we don't have to take care of this directory structure. Everything we will do from our command line, from our Visual Studio Code. So now I will switch to AWS back. I will save it. And if I again run AWS in it, it will just verify its database, its binary is available, latest version. If its latest version came on HashiCorp, then it will pull down the latest version. Because whenever AWS release some new feature, so HashiCorp will also update its binary that can manage that latest uh, services provided by that specific cloud provider. Okay, so we got the point how provider is working. So provider keyword we understand. The next thing we have to understand is the resource. Just to memorize this resource keyword, I just press enter and all the syntax is completed. And here in this double quotes, all the resources provided by AWS so far are listed here. Just name any resource, just like AWS underscore VPC, okay, AWS EC2, AWS S3. So this Terraform extension and Visual Studio Code make our life very easy to write the code. So with this way, nowadays developers are writing their code, even in Java, whatever programming language. They are taking the leverage of specific extension and they are taking the leverage of this Visual Studio Code. Okay, so for example, I want to do for VPC. So what I want to do for the VPC, I want to work with, create or work in the VPC or any specific resource under the VPC. Okay, so these are all the resources we can create in the VPC. Okay, so I just want to manage my resource of VPC. Now again, I just press enter. Here, what should I write here? I don't know. Again, so again, I will go to my documentation. Here, I will search for uh, AWS uh, resource VPC. So here I can, sorry, here I have to, in this variant, yes. So here all the VPC related documentation is listed and I want to manage. So these are all the resources, whatever listed there. So I want to manage only AWS VPC. So this can be the syntax of the resource I want to create by using the Terraform. Here you can see the Cedar block. This is the bare minimum configuration I must have to do because it will only ask for the Cedar block to use, the bigger subnet that we discuss here in this diagram, this subnet. So I just need to provide this information. You can go through this whole documentation. You can see whatever else I can add in under the VPC. So I will just copy this and I just put it here. So I want to create my subnet like 100 dot 100 100 dot 0 slash 24. Okay, so what I did after providing my provider, after selecting my cloud provider, I uh, want to create a resource. Just roll over here, it will give you the information. What is this resource? Just roll over the mouse here. It will give you the information. What is this resource? Okay, and here it should be some meaningful name. I can say VPC underscore by underscore infrastructure as code. Just some meaningful name I want to give. So VPC name will be in VPC created by infrastructure as code. So let me just save this. Now I want to implement uh, this VPC or in my by using the user what I created by the IAM. I set up the keys of those user, the access key in the AWS CLI. So Terraform will use that specific user. And this region is overwritten by the region we define in AWS CLI. So whenever we will use the AWS CLI, it will use its own region. And Terraform will use this region. So now we just define this. Now we can run Terraform plan. So Terraform plan command, you can say, will check the syntax error of your code, and it is a dry run. It will give you the information what is uh, what will be created, what will destroy, everything it will report. So it is recommended to use plan before implementing, before applying the code. So it is looking the code, it verified, and it said response is it will create something. Terraform will perform the following action. This AWS VPC will be created, and you can see we just define this value. These are all the rest of the values are set to default. We can set these values. We can just take the reference from of these values, add here if we want to customize. So rest of all values are by default. Just like you can say DNS support is by default enabled in AWS VPC. So if you want to customize anything, you can add, and you can also add the tag. So tag I have not added. We can add the tag, something like tags, and here I can, you see, I just put the curly braces. It gave me the information, the key and string. So the tag is something I can say name is equal to VPC VPC by infrastructure as code. The same tag I want to apply. Save it. Again run to validate the code. Terraform plan. So it gave me an error. I believe it should be in double quotes. Yes, now it's good. So one resource will add 0 to change, 0 to destroy. So far, uh, it will only create one resource, that is only VPC. So I will now run the third command, apc apply. So Terraform init you will run only once, or if you want to update the AWS provider database. Terraform apply ran and gave us the same output for plan, and it is now asking us to type yes if you want to apply these resources. So in this region, it will create this VPC with this tag with this prefix. So it is done, and VPC is created with this ID. So now let's go back to AWS, just refresh. Just So here you can see in this region, North California, US West 1, this VPC by IAC is created. Okay, and the subnet is same, whatever we used, and the tags, I believe if I select this, the tags, yes, the same tag is set up here. So this is done now by Terraform. But so far we have not created any subnet, any route table, nothing is created. Okay, so this route table I believe came by the default VPC. So we just created this VPC. Now we have to understand the provider, we understand the resource, so we can create any resource. Similarly, if I type resource again and I type AWS underscore, I want to create AWS underscore VPC underscore subnet, or I can just say VPC, or I can now say something like AWS underscore VPC dot VPC. So with this way I can create, but I will show you how to create further resources. But I just showed you one example. We will create the another thing that we have to understand is the data. Data, I just roll over this mouse here. You can see a data block requests the Terraform read from a given data source and export and the result under the given local name. The name is used to refer this resource from elsewhere from same Terraform module. So data, we can fetch some information about our AWS, different resource information we can fetch by in the data. You can think like this data is just like a variable. It will take the input in its variable, we can say. So let me type AWS, just like availability zones. Okay, and I can say AWS underscore AZ. Okay, so I just gave this name and I use this resource. Okay, so what this data will fetch here, all the availability zone. Let me check availability zones. This is zone and zones. So I want to fetch all the zones. Okay, so AWS AZ underscore, I can say info. So this is just my own name here. Okay, so in the body I don't want to put anything, and the another uh, keyword, another function you can say of the Terraform is output. So far what we did, provider, resource, now data and output. So output will be used to print the value of the variable, value of this data. So how can I print? I can say value is equal to what I want to print, data. So as I wrote the data, it automatically fetch all the information of this data. So AWS availability zone dot AWS AZ info. Okay, and then again dot. So I can fetch the IDs, names, state. These all information I can get from this data, whatever is pulled by Terraform. So for example, I want to use the names. So this will print on my screen when I will run Terraform plan or Terraform apply, it will not make any effect on the resource in the AWS cloud, but it will show us something. Because why I did this? Because when we create the IAM user, we have not gave the AWS web console access to the user. So how user will get the information about availability zone? So with this way, the user can list down all the things, all the regions. If he want to list down, he can use the regions. He can. So far I am just listing down whatever resource you want to list, he can list down. So here I just concern about the US West 1 availability zones. So the names it will be printing at here, you can say some meaningful name, just like I can say US West 1, US West 1, uh, easy names. Okay, availability zone names. So let me just save this and it just run here the plan. So you can see here the output. Uh, one add will resource, but that add resource is already there. And this variable, this output, you can see we have two availability zones in this region. Okay, let me just change this region to US West 2, and US West 2 has four availability zones. Just I save this and I am just going to comment out this this section because I don't want to create this resource in this region. I just want to fetch the information about the availability zone. Just save it and again plan. So one thing more I have to change, it's to US West 2. The variable name should be. It does not matter, but its information should be correct. So it listed down as the four availability zone. So here I explain you how you can fetch some information. For example, the list of Amazon machine images AMIs, the list of different public IPs associated with some stuff. So we can use this way. Okay. So there can be, hundreds of example of pulling down some information about some resource. Okay, so whatever user I am using right now, that user has only access on VPC. You remember yesterday we created this in last session we created this user. Okay, so we pull down the information of availability zone. Now let's make some changes in this data. Let me create one more data, and this time I want to fetch about the VPC, information about the VPC, created VPCs. Why I am doing only for the VPC? Because this user has only the power to work in the VPC. So one is VPC and one is VPCs. So all the VPCs I want to fetch, and I can say here AWS underscore vpcs underscore info. Okay, and I want to make an output, another output I can create, and in this output my value will be from data dot. So this time when I press dot, it showed me you have two uh, data defined. So which one I want to use? VPC info dot. I can fetch the IDs tags. So for example, I want to fetch the IDs, and I think we can also fetch the cedar block. Yes, cedar block, I believe we can also fetch. Let me just test it. So here, yeah, this is wrong. So it is only sporting whatever the dot. When I press the dot, so I can fetch the IDs. Okay, so let me and just make this name meaningful, and just switch back to West 1. Here, West 1. Here, the name I can say the VPC associated with this region. I believe we can use spaces. We just test it. Yeah, spaces are not allowed. You must have to use hyphen or I think underscore. Okay, perfect. It ran and it gave us the two outputs information. One the availability zone and one the information about the VPC ID. Okay, so this ID we fetch down. So this output value, so far we understand if we declare some data, but sometimes we don't need to use this data. We can directly fetch and present the value of some created resource by this Terraform. For example, I create this VPC cedar. Okay, this is already created. I am going to save this, and I want to fetch VPC associated with this region, and I want to fetch the value not from this data declared but directly from this resource what I created. So this is AWS VPC and dot VPC by IAC. So I can, if direct type AWS underscore VPC dot, it automatically complete from this resource, and then dot, we can fetch a lot of all the values related to this VPC subnet. Just like I want to print its cedar block, but cedar block is created by this resource. Okay, just I'm going to give you the another idea how the output value can be vary. So just I save this and I just again run the plan. And this time you can see given this output, and this output is the cedar block is this. So just you have to understand sometime we need these variables, these values as an input to perform some advanced level of functionalities. So here we understand concept. Again, I'm going to repeat the provider we understand, the resource we understand. Resource can be any resource, whatever rights the user has, that resource can be created. Data we can use with any resource, whatever resource that user can read, that can be the input of data, and that data you can print in the value of the output, or you can directly use the some existing resource created as the value of the output. So if you understand provider, resource, data, and output, now you understand almost you can say the maximum part of Terraform. The whole story is going to revolve across these four things. Okay, the provider will be static. One time you will define, you don't need to change. Resources, you can create multiple resources based on the resources subparameters. You can use these values to customize your resources, and you don't need to worry about the values that are the uh, associated with specific resource. You can straightforward go to this documentation and you can search here for that specific resource. Okay, now let's start with some another resource creation process. So I am going to uh, okay, one more thing about the value. Just like I presented here the list of availability zones. These are two. There is a function length. We can use this length function, and this length function will use this variable as an input, and what how many output are coming, it will show us its value. So just save it quickly, run this again. Uh, sorry, I misspell the name. I have not take the leverage of this auto completion. Okay, so this time you can see it gave us the value 2. So because it means we have two regions. So we can apply this length to calculate the number of some specific resource available. Okay, now we will create some another resource like uh, resource VPC, AWS VPC subnet. So AWS underscore subnet, and the name of the subnet I can say just here, the name of this resource in the Terraform, I can say, for example, the public subnet I want to create. Okay. Now again, the what child values it could have. So we can take the documentation from here, AWS subnet. Okay, so you can consult this documentation if you want to. get more information. Okay, so here we can define the cedar block or from with which VPC it will associate. So what I did, I just created subnet, and these values we can set in the uh, body of this resource. Okay, so these values are mean count how many subnet we want to create. So here we can define, you can define here some specific number of subnets you want to create, or if you want to create in any specific, all the specific, all the availability zones, then you can use this one as a variable for this count. Okay, so we calculated the two value here. So this will replace with the two, whatever the availability zones are available. Then VPC ID. So VPC ID is AWS VPC dot VPC by IAC. So VPC by IAC dot ID. You see, it is doing the auto completion. Then this cedar block. We can define the cedar block manually here too. But this function will perform the dynamically creation of the cedar block. Uh, it will take this VPC cedar block AWS VPC by IAC dot cedar block. This information we fetch down here. Okay, so it is the complete cedar block. This next value 4 is you have we have the cedar block 100.0/24. It's mean the last octet 8 bits are the host part. So how many, when we are going to create the subnet, how many host bit we want to add in the network to create the further subnets. So if I type here 4, it's mean I want to use 4 bit from this last octet. So 24 plus 4, it will be /28 subnet. So with how many subnet it can create, it will create. So if I type here 3, so it will use 3 bits here. So 24, 25, 26 and /27 will be the subnet. And how many subnets it will create with /27 we can calculate. Okay, so to just do this calculation, I will open here subnet calculator. Let me just quickly calculate. For example, I want to create a /27 by 100.100.100. Just calculate this. So these many subnets it can create. With /27, each subnet has about 30 IPs. This is the network ID, this is the broadcast ID. Okay, this is network ID, this is broadcast ID, this is the subnet. So if I will change this subnet with so we have 1, 2, 3, 4, 5, 6, 7, 8 subnets we can create. So if I change this to, for example, 2, I'm just giving you random examples. So then it will be 24, 25 and 26 /26. So if I just change here with 26, so how many subnet it will create? Only 4. So we have to make some sense, mean either we have to create a public subnet and private subnet, so our subnet should be good enough because we only have 254 IPs. Or you can extend the range of this cedar block. You can change this to /16. Then you have enough number of bits in the host and you can divide in further subnets. Just for example, we use slash 24 to understand the smaller subnet to get the idea how we can divide it. So this two are the borrowed number of bits we want to get from the host part to create the subnets. So for example, I am going to create 5. So in the case of 5, 24 plus 5, it will be 20 slash 29. Okay, so 4, I believe 4 is a good idea. And just a minute, let me. Yeah, 4 is a good idea. In case of 4, it will be slash 28. Just calculate it. And here we have a lot of subnets, and each subnet has 15 IPs, 14 IPs. So I will use 4, and this last parameter, this is the count index is the variable. So this it will create two subnets because it has two availability zones, so it will run 2 times. First time this count index, you can say it's a built-in variable of Terraform, and its first time its value will be 0. Second time its value will be 1. So I can write like this. So while first time its value will be 0 mean use the first subnet. Second time its value will be 1, it's mean use the second subnet. So these subnets, this first subnet is the 0 subnet. This is subnet number 1, 2, 3, 4, up to maximum number of subnets we have. So here this value is doing the calculation of which subnet number has to allocate to which availability zone. So first availability zone will get the 0 number of subnet, second will get the first number of subnet. First two available subnets will be used, this one and this one. But if I want to allocate this subnet and then this subnet, I don't want to use this subnet. I want to use this subnet as a private subnet. Then dynamically what I will do, I can say here star uh, star 2. So first time its value will be 0, 0 star 2, 0. First subnet will be used. Second time its value will be 1, 1 star 2. The second subnet will use. Then I need to type here 3. Sorry, 2. So 2, the second subnet is, this is the second subnet. This is 0, 1 and then 2. So this subnet and this subnet will be used as a public subnet. This will be skipped. So when we will implement it, you will see the same way this subnet is allocated. The next option is this is a public subnet to automatically assign the public IP to the EC2 instances. It's set to true. You can set it to false if you want to, but it's a good idea if you are going to set up an EC2 instance in public subnet. It should have the public IP. And then the availability zone. Availability zone, in which availability zone I want to create, this name is wrong. It should be this one. Okay, so and then again the count index. So first time its value will be 0 and then 1. So starting value is 0 corresponding to the instance. So this variable will select the availability zone. Okay, and then the tag, it will apply on each availability zone with this way, the same way we apply the tag here. Okay, here the tag is name public subnet and then the count.index, same variable. First time its value will be 0, second time it will be 1. or you can put here some *2, then it will change the value, but it's better to use the sequence number that is defined by this variable. So I explain you everything in detail. So AWS subnet public, and name is public subnet. Let me just save this, just run the plan. Just to see any syntax errors. Okay, everything is good. No error reported. There, you see the cedar block is 28, and the first subnet will have this cedar block, the second subnet will have this cedar block. Okay, so this zone will have this cedar block, this zone will have this cedar block, and if I compare this from here, you can see slide 32 is the third one, sorry, second one. So this one is skipped. So now let me just again, to clear the concept, just remove this *2. Then it will not use this subnet 32. It will use this 16. Just save it quickly again, run, have a dry run. Okay, so this time you can see the 1B has the second subnet, this one. So I hope you got the idea how we did this dynamically, the first subnet and second subnet. Okay, so now I will apply this. Yes, it is trying to create the subnet. Just go to console, click on subnets, refresh. You can see the subnets are created and their relevant subnet IDs and the regions, availability zones. Okay, so everything is done by Terraform. So with this way we understand a lot of things. First of all, we understand the Terraform code, how to write. We also understand how to troubleshoot, how to do the dry run, we can use the data and output variables, how we can take the leverage of these variables inside while creation any resource. We created two resources. We create VPC, we create subnet. Similarly, we will create each and every resource for the DevOps related or whatever infrastructure we want to set up on AWS. So we will use this resource keyword a lot of time, resource utility a lot of time. So this session was to just give you the idea, the syntax and the usability, and to understand the documentation of Terraform, and to understand the utility of Terraform, how to init, how to plan, how to apply. And the last thing is, if I want to destroy something, I will write destroy. So Terraform, whatever is written in the main.tf, will be removed. So what is the benefit now if you created hundreds of resources on AWS manually? So there are quite chances you will forget some resources to delete and your bill will be going very high. So when you are creating the resources with Terraform, you just need, if you want to delete the resources, you will just run the destroy and it will delete all the resources. So there are no chances that your some resources are running in the background that are creating bills for you. So now these resources are deleted. Just go to here, just refresh. You can see it's gone. Let's refresh. It is gone. So in next session, we will set up all these resources. We will set up all these resources by using the Terraform. We will just take the documentation, uh, leverage to understand how we can create security group, subnet, private, public, route table. I explain you in detail that public and private subnet we can create, and when we will define two resources, how we can allocate different subnet to different for the public and private. So every time it will try to allocate the same subnet ID, and that will be used by the public now first created subnet, then how it will allocate to the second one. So we will multiply the last value with some value to make a unique value. So we can generate the odd values for the public or even values for the private. So that will equally divide the subnet in between these public and private subnet. So we will do this practically in this next session. Everything we will create by Terraform. So now we are on the highway, and now we can have some better speed to use the Terraform to uh, to create the resources on AWS. So our target is to understand all the AWS DevOps related tools. First, I will create by console, and then uh, we will use the Terraform to create the same resources. So I hope you are good. So in the next session, we will continue with this rest of the VPC resource creation.